there were two or three in the first 30 years of that where I actually managed to stay awake through the whole thing. Right,
Only two or
every
three.
yeah,
That's funny.
frustrating too.
It's frustrating. I'll bet you that is a very popular time for people to take naps.
Wouldn't surprise me.
Yeah,
So yeah, you've just hit that wall. That's all.
that's it, huh?
Just turn off the microphone, and no one will hear you snoring.
Snoring. Oh, wow. I'm looking at a beautiful Explore Scientific 8-inch f3.9 reflector on on a some sort of German equatorial mount on an observatory from Harold Locke. Very
Hmm,
cool.
nice.
Yeah, way cool. It's fun to see that stuff. Okay, here we go.
It is, but you know how frustrating it is that you left Mead. I traveled the world finding Mead avenues and Mead Street, and Mead Lane for
I
you.
know you did. Yeah, it was cool
And
to get those pictures too.
there's
Yeah.
no, explore is not a road.
Explorer, there's no Explorer Road, and there should be. There should be an Explorer Way, Explorer Road, Explorer Avenue.
JPL does actually have Explorer Road,
Yeah, okay. That makes sense.
but so it just took all the fun out of travel.
Aw. Uh, I'll share this a little bit. This one's going out to the Astronomical International Group on Facebook.
Oh,
Yeah. And the Alpo Youth Program. So, how many lunar eclipses have you seen, Steve?
I haven't counted that. I
You
haven't
can
even
count those, huh?
tried.
Mm-hmm.
just about just about every partial or total umbral eclipse that has been visible from California, I have seen or tried to see since 1963, give or take. And
Yeah.
63 was a cloud out.
Oh. So this is a little bit of a visualization of, totality of the moon and where it's going to be. But and here we are. Howdy, everybody. Let me bring in Steve Edberg here. Steve and I have been friends for a long time. Since the 1980s, I met Steve about 1985, 1986, and we were all about Halley's Comet at the time. And Steve was working at the Jet Propulsion Laboratory during this time and involved in something called International Halley Watch. To my recollection, this was one of the very first professional slash amateur collaborative programs. And I don't know if it was the first that JPL did, but it was exciting to be part of it. It was exciting to be taught by Steve on how to observe faint stuff. And it was a thrill for me to be able to see Halley's Comet way back in '85 before everybody was talking about seeing a tail and giving great remarks on those observations. So we were, I was definitely in that early group. Since that time, Steve has traveled the world to chase eclipses. He's been with the Jet Propulsion Laboratory for, I don't know, 4 or 5 major missions, including the Cassini mission to Saturn, the interferometry mission that I think still has to take off. I don't know, I'm having a brain fade right now, Steve. Maybe because I'm so tired at 4 o'clock. But the mission to Jupiter, Galileo mission, and maybe 1 or 2 others. What am I missing here, Steve?
Space interferometry. Oh, the Comet Rendezvous asteroid flyby.
Okay. All right. Very cool. So, and you were a professional astronomer before you came to Jet Propulsion Laboratory.
That's right.
What was that transition like for you? How did you get to work at JPL?
Well, it was mostly a matter of applying, and at the time they needed somebody. The optics division needed somebody to work on the Galileo camera and help with getting it tested. I'm not an optical designer, but they needed somebody to plan on how you test the components and test the subsystem and ultimately test the system. And I wrote the initial versions and a revision or 2 of the component level testing that was going to be required to make sure all the parts worked when they were assembled, and the first draft of the subsystem level testing that was going to be necessary. So for that reason, I claimed that every picture that came back from Galileo is mine.
Yeah. In a real sense, part of it was. That's true. That's great.
So
well, and what do you think is your proudest moment in all of this this time doing professional astronomy in JPL? What do you like to be or would like to be remembered for?
really, I don't think of what I do as a proudest moment kind
I
of
see.
thing. I will admit to you. Um, for me personally, Halley's Comet was definitely the most fun.
Yeah.
But the second part of that that was most intriguing was when I moved kind of sideways and went from planetary astronomy with comets and asteroids and planets and rings to stellar astronomy and into a field that I had not worked with really at all, which was interferometry. And the space interferometer mission was something where I got to participate in what I ended up calling foundational astrophysics. Because even though, and I'll admit, when I started, it was like, really, is this going to be at all interesting? Because the whole idea of the mission was to do astrometry, the measurement of positions of stars in the sky. And how interesting could that be? And it turned out that it was foundational. It had applications from even within the solar system in some sense, and clear to understanding cosmology better. And the example that I can give you for that is that this instrument would have made it possible to see proper motion of stars in the Andromeda galaxy. Now, what does that mean? That means in the case of this, astrometry allows you to see the motion of nearer stars against background much more distant stars. And with optical astronomy and the older methods, you can do that out to maybe a few hundred light years. This would have allowed us to actually make measurements of the motions of stars out to 2.5 million light years away.
Wow.
And that is mind-boggling in it of itself. We would have been able to detect the gravitational effects of an Earth's mass planet orbiting a sun-like star as much as 30 some light years away with
Wow.
all the same technique.
Yeah.
And measuring, getting actual distances and very good distances to some of the standard candles, the stars that we use and assume as best we can measure that they are all the same brightness for the way we can detect them, would have been extended as far out as the Virgo galaxy cluster, Virgo cluster, which is like 50 million light years away. And that would help us to actually stabilize the whole understanding of the Hubble constant, how fast the universe is expanding, how old it is, and all the rest. And that's why I was saying it was doing foundational astrophysics.
I see.
And it really grew on me over time when I started realizing what the potential was. It wasn't the measurements that mattered, it was the interpretation of those measurements. And that's where the big science was. And big and science both need to be in capital letters for that, because that's what it was.
Yeah, that's cool. That's cool. Well, we're glad that you're here with us this afternoon. We have this beautiful lunar eclipse that's going to be coming over the western part of the United States. Unfortunately, here in Arkansas, we're going to miss it, but we'll get a partial, of course. But the total and seeing it change the colors and all the rest of it, and doing astronomy outreach at the same time. You know, I often like to be on a street corner somewhere to let people witness something like that. But it's not as spectacular as a total solar eclipse, but still something very odd about it, and in the way that you see the shadow creeping up on the moon, and then watching it dive into those colors of orange and deep orange, umbra, whatever, and you know, it's just beautiful. And so Steve will be here, or is here, to kind of answer our questions about this, but to give us a full overview of what the total lunar eclipse is all about. So I'm going to turn it over to you, man.
Okay, thank you, Scott. Let me share my screen and open up the presentation here, and we'll go on from there. There we go. So just looking back, I eventually decided that the best description for myself at JPL was a utility astronomer, because of the wide variety of things that I was doing at JPL.
Mm-hmm.
And then, of course, the other thing that I was doing on the side for a significant number of years was the Riverside Telescope Makers Conference and the Astronomy Expo. So that's why that's up there, just by way of introduction.
I think you did that for about 20 years or so.
Yep, a little more than that. Mm-hmm. And I was a participant on the board and planning and operations longer than that. I just ran the show for 21 years. So.
Right.
Which was good. I'm glad to have contributed that.
Yes.
So let me talk about eclipses. This is a collection I took of the total lunar eclipse back in October of 2014. It shows the basics of it, and I'll get back to this picture in a little while, but it basically shows from left to right and then top to bottom on each line the phases of a total lunar eclipse. That's what we've got visible here. I'll show you the range in the world of who sees what, but basically, as Scott mentioned, this is a Western US and Pacific Ocean, mostly eclipse, that's going to be visible out to some of Asia on the other side of that. And you see here a couple things. One is it's sometimes hard to get the exposure right, and I'll jump ahead and point that out now. This is underexposed. This is a lot better to what photographer would like to get. And I'm going to save the rest of the conversation about that to later. But this is what happens over approximately 5-hour period. With Scott, I agree that they can be very eerie. What I get most excited about actually is just seeing how dark the sky gets once we get into totality. And even if the moon is not as dark as it was in these pictures from 2014, you see so many more stars come out, and it just is a very, very different kind of view with that orange globe up in the sky, but with stars surrounding it instead of it blasting things out when it's the full moon, which we usually see. So how do we get an eclipse? And what this is the answer to that question. And of course, there are a number of things. This is actually, after looking through it, courtesy of NASA, somebody put together a really good one. I'm going to show you another one in a few minutes to go into a little more detail about what's going on. What you have to realize is that this is not to scale. Even Earth and Moon do not appear to be quite the right relative sizes, but they're close enough for you to see the alignment, and that is the key to this. The Sun, Earth, and Moon are aligned such that the Moon goes through Earth's shadow. In this particular eclipse, and again, I will show you show you the specifics of that, the Moon is missing the center of the shadow, but the shadow is large enough that all of the Moon will go into it. And by into it, I mean going into the umbra. That's this cone-shaped shadow. Oh boy, shadow.
Yes.
That is cast by Earth from sunlight. But there are other portions of the shadow where the sun can still be seen. And that area is called the penumbra. Here it's on the top and on the bottom, but it's actually all the way around, and it's a cone the other direction, which means the Moon can be in some sunlight in that part. And then outside of the penumbra, all around this, the Moon always gets direct sunlight. And so when we get an alignment like this, we can do that. Now, if you're thinking about it, you say, well, wait a minute, why don't we get one of these every month, every 29 and a half days? And the answer to that question is that the Moon's orbit is tilted with respect to Earth's orbit. And so there are only 2 periods each year, about 6 months apart, when the orbits, the tilted planes of the orbits cross, and the Moon and Sun are there at the same time, and we can get at least a partial eclipse of both Sun and Moon. Those are called eclipse seasons. We have them twice a year. Occasionally, just to be clear, we can get 3 eclipse seasons in a year, but that's not too common. And that would be a January, June, December, or January, late June, early July, December set. And that's the only time you can really do that. So what happens is it's in the shadow, but notice that they show the Moon in this getting a little darker here. It's bright outside, would be bright outside anywhere in the sun. In here, it's darkening, and then it turns this coloring. And the coloring has to do with the fact that it's not just Earth's shadow is there. If there was only Earth's shadow, the Moon would go completely black. Occasionally that happens during total lunar eclipses, but that usually requires a pretty heavy layer of volcanic dust in the stratosphere for that to happen. Back in 1963, that was one such case. And even the eclipse after the explosion of Mount Pinatubo in the Philippines back in the 80s, I guess that was late 80s, the eclipse was quite dark. I actually flew out to see totality in Virginia, and the moon did completely disappear. It was kind of hazy that night, so I don't consider that it was absolute. It was definitely not visible from Virginia, but from a place that wasn't as hazy, it might have been just a very, very dark brown eclipse, and I'll talk about that in a few minutes too. But the moon just travels into the penumbra. Usually can't see it until it's about half an hour in, and then you only start to see a hint of darkening. It gets to the umbra, and that is quite a bit darker. It'll disappear in the umbra, or not disappear, but be all the way to anywhere from a bright orange to disappearing. I'm expecting a medium orange this time to make some kind of prediction. And then it passes on out, as you saw in the previous page. So it goes in, gets dark, has color. Notice how the area and the direction of the penumbra closest to sunlight moves around the disk as the moon moves through the shadow, and then it pops out. Notice that the orientation of the shadow is quite different on the inbound side and on the outbound side over here. So that's what's happening. Now, why do we get that coloring? And nobody has to read this long explanation, though it's a good one, if I may say so myself. But the trouble is it's long. Basically, what's happening for getting that color is that Earth's atmosphere actually bends sunlight towards the inside of the shadow. And so we are actually getting colors, all the colors getting bent in, some of them more removed than others. Red, orange, yellow get through Earth's atmosphere more easily. That's why at sunset you see a reddish sun. Or sometimes it's orange, and sometimes it's so bright it's just yellow and you don't want to be looking at it and hurting your eyes as it sets. But all of them get bent. They also all still get mixed by the time they get to the moon, and so we may only see the yellow, orange, reds that get through, but blue is getting in there, and it can look quite gray in contrast. So, and the reason I ended up making this was because NASA had published a different explanation of the coloring that was just not right and very misleading, and I just had to say, come on folks, maybe we can do a better job for this eclipse, in fact. So that's what's going on. This is what this Earth shadow, the moon in both of its forms, the penumbra and the umbra, and the size of the moon are all to scale here if you are at the point on Earth looking straight up to where Earth's shadow is. In other words, looking directly opposite the sun. And you can see the various portions of the eclipse. First contact, and these are in what's called universal time. You can translate that into Greenwich Mean Time if you're more comfortable with it, which is the time of day on the 0-degree longitude line that goes through Greenwich, England. And so that starts at 8:02 in the morning. Sun is up. They're not going to be seeing this eclipse. In fact, it goes all through into the early afternoon, about 2 o'clock there. And so they will not be seeing this eclipse at all. First contact with the penumbra is at 8:02 UT. First contact with the umbra is at 9:09 UT. The contact that begins the total lunar eclipse, U2, I use just so you'll know for later, I actually use Roman numerals for those. That's at 10:16. Greatest eclipse is, thought it was here. Oh, it's up here on the top. Is 11 hours UT, or actually, here's one of those things that's a little bit different. It's actually at 10:59:08.8 Universal Time. TD stands for terrestrial dynamical time, and it's a little bit different, as you can see. I will admit to everyone that I'm still trying to figure it out, but it is one of those things that's a little bit different. So, but greatest eclipse is the time when the center of the moon is closest to the center of Earth's shadow. That does not put it at the time of mid-eclipse, which would be the time midway between 10:16:39 and 12:49:03. And it's also not the time of what's called ecliptic conjunction. And that is the time when the moon's center crosses the north-south line in the sky. So there are a lot of ways of measuring things in the sky, and this just adds to all the confusion, and I'm sorry about that. But the definitions are helpful. U3 marks the end of the total eclipse at 11:41 Universal Time. U4 is the end of any umbra on the moon at 12:49, and finally the moon is out of the penumbra at 13:56. So that's what's happening over this period. I will show you a table and leave it up towards the end of this, so anybody who wants to copy it down or take a screenshot will be able to, but you'll see that. So what can you do when the eclipse is going on? There is
a Danjon scale, okay.
Yep. And it's probably a different pronunciation, but everybody I think uses Danjon scale that has been in use for decades on talking about the brightness of the eclipse. It runs from 0 to 4, from a very dark eclipse, moon almost invisible, especially in totality. And as I say, that has happened in the past. It's gone even, I could give my observations Virginia Danjon 0, but other people might have just decided it was a 1. Which is a dark eclipse, gray or brownish in coloration, and these things that you see. Here's Mare Crisium on the moon, the Sea of Crises. Tranquility Base is in here, the Sea of Tranquility. These disappear is what they're talking about, details distinguishable only with difficulty. It can also be a deep red to rust colored, a brick red. I'll admit I'm having a little trouble figuring out the difference between deep red and brick red, because I might have gone the other way with those two. Coloring of the rim comes in, and then very bright copper red or orange too, with a bluish, very bright rim. Now here, this picture that I've chosen is not actually during the total phase, or at least it looks to me like it wasn't. I'd have to go back and check the timing, which I have on it, but I just wanted to give you a good example to look at. Now, what about colors? And this is something that in the day of PowerPoint perhaps is potentially useful. And so I pulled out some of these. I think I didn't finish all of them, but I tried to get a collection that looked like they might be useful for comparing colors. With the descriptions in the scale, and even my trying to show you these colors and how at least they're repeatable by everybody matching these 3 values in PowerPoint, you could actually try and define the colors that you were seeing during the eclipse. Not a bad thing to do. The hard part is getting your computer out under the moonlit sky to actually see what those colors are, and then decide, well, what do I do because of that bright green, because the moon's not centered in the shadow. And so it's one of these things where the observations are valuable, and yet it's very hard to calibrate various people's perceptions and really try and understand what we're seeing. Another thing that you can look for during the eclipse is to make sure that the edge of the moon, edge of Earth's shadow, the umbra, before the moon is completely into the umbra and after it begins to come out, and see if there are any irregularities. A number of years ago, there was a lot of commentary on the fact that it looked like there was a notch or a discontinuity, a extension of Earth's shadow sticking out. And when weather satellites were studied to see what might have been there, it turned out there was, in fact, a very big storm on the sunrise sunset line around Earth, and where the shadow would have been made, and that storm was apparently extending the height of Earth's shadow because it was cutting out more sunlight than usual. So that's fun to look for as well. Anybody interested in photography, I started to say this already, but I'm going to go back to it. I underexposed on this first image. If you're doing digital, you're going to do fine because you can always check the images on the back of your screen and make sure that they look reasonable, and you know, taking a few extra on either side will get it for you. But you want to have something probably more like this than this when you're doing your set of pictures, and that's fine. So, you know, here's Earth's shadow going in, further in, all the way here, and notice that I put these two together. There was a reason for that, and that's because these were taken within the same minute.
Oh.
I made a long exposure so you could start to see the color here, but that badly overexposes the still illuminated portion of the moon. Then into totality, I pointed out earlier that when it's close to the shadow, you have a bright edge, and that bright edge moves around until the moon pops out again. And here again is a pair that were taken in the same minute. You can still see the moon in totality over here. They have no view of the sun on this side of the half of the moon, but on this half, they're in not full sunlight, but a partial eclipse by Earth of the sun. And then you can just follow it going out again, looking for any darker areas that seem to be persisting. Not here, but you always have to watch out because you don't know if it's just caused because this portion of the moon reflects less sunlight than down here, for instance. These are the lunar highlands are bright, and the mare, which are actually flows of basalt that we see here, are darker. The other little gee whiz thought is that the moon only reflects about 11% of the sunlight falling on it. And just to give you something familiar that is like, that would be like a fresh blacktop on a roadway or on a driveway or something. It's fresh, not dirty, not driven on, but fresh. It reflects about 11% of the sunlight. So the moon is not a bright reflector, and yet at night we certainly feel like it is. And you have to expose accordingly to get pictures you want. So where's the eclipse going to be visible? Well, I told you all those times at Greenwich Mean Time. Greenwich is right about here where my arrow is, and you can see no eclipse visible. Over time, the portion where all of the eclipse visible runs from P4 on this side out across the Pacific over here to these Pacific Islands. New Zealand even gets to see it all, and even just a little bit of northeastern Australia gets to see it all, out to Japan, most of Japan being able to see the whole event, Siberia up here, and some of these Pacific Islands here are going to see it. The rest of the world has, the other 2/3 of the world roughly get to see either this, some fraction of it on each side, and this portion doesn't get to see it at all. So it's roughly a 5-hour event, and this is actually the last one total that we're going to see all of for several years. If somebody is curious, I can give you some additional dates in the future. One date I will tell you, though, is in June of 2029, and I'm going to go back for a second here. Yeah, June of 2029, it's going to be very, very close to central lunar eclipse. And what here is a total duration of about an hour and a half will get at least 15 minutes longer because the moon is going to be almost exactly centered in Earth's shadow in 2029, June. South America is privileged to see that one.
You know, when I look at that color chart,
Yeah.
Steve,
This one,
yeah, I mean, you've got green in some of these. Have you seen a green lunar eclipse before?
no, and that's why they don't have numbers there.
I see. They just didn't translate over when you were doing the
In the
PowerPoint.
course of collecting these, I left them in, and I think this was a project I was working on, and I got distracted and didn't finish. And then I came across it when I was pulling this together. I said, I got to show this.
Yeah,
So no, don't forget the green.
forget the green. Okay, all right.
And in fact, it looks like I need to chase down this one because this one is a nice in between for these two.
Right.
Get them rearranged and the whole thing. It's just
all right.
But
all
so
right.
I'm sorry it's not all together there for you. But
No problem.
the idea is what
Next
I
time.
have.
Yeah, you even get a warning about it. So.
Yeah.
Mhm.
Okay, so here's the list of times. I did this with only, I'll admit, North America in mind, and all the way out to the Hawaiian Islands and Alaska. But and also another limitation is that I was looking only at, is sunrise going to matter, not whether the moon might have set. And so the blankouts here, and I'm going to go to this again to show you this in better detail, but the shaded areas here are certainly going to have too bright a sky if the moon is up to see it. But some part of these will be doing it. And here is the universal time, approximately dynamical times that are to be used. I should say approximate UTs to be used for the various events. Penumbral contact when the eclipse just begins, umbral contact, total eclipse begins, mid-eclipse, greatest eclipse. I mentioned that those can be different in time. And then total eclipse ends, the whole umbral eclipse ends, and finally the penumbral eclipse ends. And Pacific Standard Time, we get to see them all barely. Alaska, Hawaii will see them all, and Greenwich won't see anything. So let me move to that. It'll be easier for everyone to see. And I think we'll leave this up. And if we have any questions, Scott, let's talk them over.
Well, it was just a comment earlier about Pink Floyd's Dark Side of the Moon cover, which has, shows the spectrum coming from a prism. And he says, Dark Side of the Moon cover art now makes so much more sense. But,
Good.
and we have someone that has mentioned that the Earth is flat. And my response is, how flat? But on any account, thank you for giving us a very nice overview of the eclipse. If you are not ready, for the eclipse at this point, then I would just recommend that you watch this program once again. Get ready, get ready. Steve, is there anything that you do special to prepare for a lunar eclipse when you're gathering all your gear and everything?
Oh, yeah. This I I've gotten very serious about things, and as I mentioned to you, Scott, I was just working on a new telescope that I'm going to be using. Um, my preparation is actually to pull together all the times with my local clock. So for me, it's going to be Pacific Standard Time, and
Hmm.
I will write them down as you see on this table, and put in planned other times when I want to try and get a series of pictures like the ones that I showed for the 2014 eclipse, plus other things. Lately, I have gotten involved with trying to get infrared observations with no less than a cell phone infrared camera. And I've adapted it to a telescope. And with that, and it has to be an open air telescope, no corrective lenses or anything in it, but a Newtonian or a true Cassegrainian will both do that. And I have been trying to look at what happens to the heating on the moon as it goes into the shadow and as it returns. And what my images show is actually that it's no surprise, but the cooling of the moon's surface lags behind its coverage by the shadow. So it stays warm for a while.
Hmm.
And then coming out, it lags behind, warming up some. Again, not really a surprise, but
Like
it took all the
lagging
way,
what,
sorry,
seconds or minutes, or what would you say?
minutes,
Minutes.
minutes,
Oh, wow. Okay.
multiple minutes, 10 minutes, 15 minutes. And it took all the way through the May eclipse for the moon to return to full temperature, all the way to the end of the penumbral contact. The last,
Hmm.
when the moon finally was out, it was finally back to the temperature it had started with. So at least on a gross scale, with this eclipse, I'm actually planning on using a much larger aperture and longer focal length telescope to try and focus in on probably some good crater in the middle of Amare. And I keep thinking Copernicus might be a really good one
Sure.
to use, and just see how it behaves on a finer detail with that, weather permitting.
Right. Right. And you give yourself what kind of odds for this particular eclipse?
Oh, I'm a little discouraged, is what I'll say. I don't know.
Don't
Um,
know yet.
the
Okay.
weather forecasting has gotten so good in the past 5 to 10 years that I now have to start trusting them. And whereas a forecast a week in advance that it was going to be raining for the eclipse, I would say, nah, I'm not going to start worrying. Uh, Now, being 3 or so days from the eclipse,
Yeah.
I'm worried because we got a forecast for rain. So now it's a matter of can I find a place in driving distance that is likely to be free of clouds
Yeah. Yeah.
too?
You might have
So
to go over a couple of mountain ranges to get out of
uh, the good news is that I could even drive as far as Las Vegas if I really am motivated. I haven't decided if I'm that motivated yet.
right. Well,
So
well, I hope it you get some clear skies. It'd be cool to see some nice, uh, you know, total lunar eclipse images. Uh, I'm curious if there's more that can be learned scientifically by amateur astronomers about the eclipse. Maybe something that might be considered esoteric, but still doable by an amateur astronomer.
well, I think someone starting to do and keeping the records for and knowing what they did a year ago and 2 years ago and 5 years ago, or
Hmm.
if you're starting, keeping those records so that you can keep repeating, but with the same telescope, the same, ideally the same sensor on the camera, um, keeping track of what the shadow looks like at the same stages crossing the moon, I think could be a really interesting thing to do. And honestly, I haven't thought of doing that, but now with till now, but with digital cameras, that is possible. And so having that would make for an interesting presentation on what Earth's weather has, if it has evolved over that period. And that's why this is a multi-year project.
I see.
That goes slow, but I pulled out my book, my canon of eclipses, and so for starting on the night of November 7-8, I want to emphasize that to everyone. It's the night of 7-8. It's not the 8, not 8-9. It's 7-8. We have an eclipse, and most people will see a fair portion of it. The next is a penumbral eclipse, which at least over North and South America is going to be completely invisible. After that, if you're on the East Coast, there's a partial lunar eclipse where a part of the moon gets into the umbra, which someone could use. And that's why I say getting those pictures and knowing the times and where the moon was in the shadow at the time is the important part of that activity. But that can be done getting a canon of eclipses and studying what's coming up. And you can find all this on the web now. And take those pictures. So then we come up on 25th of March, 2024, and it's only a penumbral eclipse. I'll bet you it'll be detectable because just about the whole moon will get into the penumbra, and North America, South America see most of it or all of it. Another partial lunar eclipse, a little bit in the umbra. September 2024, it has a total. March 2025 has a total eclipse that is going to be visible in North America, actually centered on the meridian of the Texas-New Mexico border.
Okay.
So there's a lot coming up if you pay attention and decide you have a project you want to do. So I encourage anybody who's interested, just do it. I've gotten very excited about lunar eclipses now because I've got projects I like to do.
All right. Well, thank you, Steve. Thanks. We will come back with another episode of Eclipse Experience here in another week or so. We've got people that will be telling us how to prepare your community for a big total solar eclipse, and so which we have coming up in 2024. But we'll keep you up to date on these things as we go along. But I couldn't resist having Steve come on to talk about the lunar eclipse. That's coming up here on the 7th and 8th. So. We wish you have a great weekend, and until that time, do as our friend Jack Horkheimer always used to say, and that's keep looking up. So thanks a lot. Thanks again, Steve. Thanks to the audience, and we'll see you next time.
Clear skies, everybody.
Yeah.